Now we'll move into working some problems using the trig ratios where we'll find missing sides or missing parts of the triangle. So we really only have a couple things that we could be looking for. We could either be looking for a missing angle or we could be looking for a missing side. Now, right now in this particular lesson we're going to start with missing sides. The missing angle part will be relatively straightforward since we know that the three interior angles of a triangle add up to 180 degrees. So we'll use that concept for right now. In later lessons we will not be given enough angles to determine that, and we'll have to come up with another way. So now a couple things from a directional standpoint that you'll want to take note. If it asks you specifically to solve for or to find a missing value, like say a variable x, so that'll represent probably a side length, then we just find that individual part. However, if it asks you to solve the right triangle, this is a very important distinction. Solving the right triangle implies that they want you to find every missing part. Generally speaking, there are 6 parts, 3 legs and 3 angles. And so 3 of the 6 parts at this point should be given to you. So whether it's a combination of sides or angles will depend on what you're looking for. So using that information, we'll just go ahead into example number 2. Now, we will be using our calculator in this particular part, so you want to have your calculator handy. And keep in mind that your calculator can evaluate other angles besides 30, 60, 90, and 45, 45, 90 triangles. So we will use that to our advantage. Alright, so example 2 says to find the value of x, which is a side length. So we want to take a look. What is the relationship from the 60-degree angle to x? And we know that that is opposite. And we are given the hypotenuse. So we kind of want to back ourselves into a trig function. I know opposite over hypotenuse represents the sine of an angle, and in this case we know that our angle is 60. So we can start to replace the parts that we already have. So in this case I have 60, the hypotenuse I have 10, and then of course the opposite side would be the missing x. And of course that's where we come up with our equation from. Now, to find x, we have a fraction here, so we're going to multiply both sides by the denominator. So if I multiply this side by 10 and I multiply that side by 10, I'm left with x is equal to 10 times the sine of 60. Now, let's take a look at how that plays out in your calculator. If I did 10 and then I do open parentheses and then I hit trig, and I'm going to do sine of 60 degrees, and I'm going to close both of those off, I get 5 times the square root of 3. Now what will probably happen for you is you should get straight decimal. That's the difference between my software and yours. So hopefully that came out to be 8.66 for you. Now what I wanted to show you is that sometimes you don't even need to put the initial parentheses around sine of 60 because the calculator will treat it the same. So anyway, work on that. If it did give you 5 square roots of 3, the way that we would change that, I would just say 10 decimal point so that I finish my answer with a decimal point, and then I'm going to do sine of 60, and it should give me a decimal now. So hopefully 8.66 is what you came up with. Okay, you go ahead and work sample problem number 2 right now, and then come back and take a look at the solution. Okay, so I'm going to start. I have 30 degrees. I have the opposite of 30, and then I have the hypotenuse, so I can say sine of 30 equals opposite over hypotenuse. Now we know the sine of 30 is 1/2, and you could actually set up a proportion here if you wanted to go that route. What I'm going to do is just use my calculator to come up with the answer, and then when I do 15 times the sine of 30, I'm going to round that off to about 7.5. Now, since you know the sine of 30 is 1/2, you could have actually set up a little proportion there and still come out with 7.5. Okay, so either way, works, but we're going to try to get you accustomed to the trig method if at all possible. Alright, let's take a look at one more. Notice example number 3 simply says to solve triangle ABC, and the fact that it simply says solve means we want to find all of the missing parts. Now, that means any missing angle and any missing side part. So the first thing that you notice here is we have a 90-degree angle and the 19-degree angle. The third angle is very simple because we know all of them have to equal 280 degrees when added together. So we can come up with 71 as that other angle. Now, this last part comes down to a little bit of personal preference. It's up to you. You can use the 19 twice to find the missing parts A and C, like I did in the solution, or if you're not comfortable yet using the reciprocal parts secant, instead of using 19, you could have used the 71 and used the appropriate part for that. So it's your choice at this point. I'll let you decide on how you want to do that. So go ahead and work sample problem number 3 and be sure to solve for all parts, missing parts of the triangle. Okay, so the first thing I'm going to do is I'm going to take 180 degrees, subtract out my 90, subtract out my 68. That should leave me with an angle of 22. So that's an angle of 22. Now, what I'm going to do is what I suggested in the last one. Let's see here. I have 22, I have 68. So let's take a look. I have A equals to 5. So I need to find side length B and side length C. And I already found the measure of angle A. That equal to 22. So I'm good there. So I got 2 more parts here. Alright, so I'm going to start off with part B. So for part B, I'm going to use the 68 degrees. I'm going to use tangent. And so for side C, I'm going to use cosine. Now watch what happens here. If I did cosine of 68, it's going to give me 5 over C. And you may not like having that variable on the bottom. This is where using sine of 22 might be more useful. However, that's going to give you the same issue. You're still going to have C on the bottom. Now, if we use the reciprocal function, so if I use secant instead of cosine, I would have secant of 68 equals C over 5, which would maybe be a little bit easier for you. You're going to have to determine what your personal preferences are and how you want to solve these. Now, let me show you a little trick that happens here. If I multiply both sides by C to eliminate that, I now have C times the cosine of 68 equals to 5, and I want to get C by itself, so C is going to equal to 5 divided by the cosine of 68. And then I make C equal, and that's approximately 13.3. Now, if you go this route, if you have C in the denominator, what you're going to notice here is that the C and the cosine of 68 are actually just going to switch places whenever you go through this process. And so that's a quick little shortcut so that you don't have to do these extra steps. Alright, hopefully you did well on that one.